So for problem 1, we're supposed to figure out whether the function is a polynomial or not. And since each term, in problem number 1, since each term can be written as, or expressed as a real number times x to a whole number power, we would say yes. So we have 3 yeses, but the degree is 4 right here. So it's not degree 7, it's not degree 8. Okay. Now number 2, f of x can be rewritten if you wanted to write this 2, 6, splitting up the fraction as 2, 6 minus x squared over 6, which can also be written as 1/3 minus 1/6 x squared. And then also in standard form, we could express this function as negative 1/6 x squared plus 1/3. And again, this expression here can be expressed as a real number, negative 1/6 and 1/3 are real numbers, times x to a whole number power, x to 0 power over here. So yes, it's a polynomial, so it can't be b or d. What degree is it? Well, it's the highest power when it's in standard form, so it's degree 2, not degree 1. And then number 3, this function can be written as a real number times x to a whole number power. That whole number is the degree, so yes, degree 0, D for number 3. For number 4, 1 plus 9 over x can be written as 1 plus 9 times x to the negative 1. Negative 1 certainly is that's not a whole number. Okay, so this one is not a polynomial. And then this function here, if you write it in standard form by distributing the x, we get x squared minus 10x. So certainly degree 2, yes, degree 2. All right. And then number 6, find the x and y intercepts. Well, to find the x-intercepts, we have to let y equal 0, and we solve this equation. At the same time we're solving this, we're going to factor out the x. We get 3 minus x squared. So if you set each factor equal to 0, we find the intercepts. X equals 0, x-intercept of 0. So each one of these choices has an x-intercept of 0. But then the other x-intercepts would be when 3 minus x squared is equal to 0. If you add x squared to both sides, you get x squared equals 3. And then you would get, by taking the square root of both sides, you get x equals plus or minus the square root of 3. And so we see it can't be a and it can't be b. So now we have to figure out the y-intercept. Well, the y-intercept was letting x equals 0. So when you let x equal 0, you get f of 0 is equal to 3 times 0 minus 0 cubed, and that's just 0. So 0, 0 is the y-intercept. So y-intercept of 0 there. So it can't be this one, so it has to be choice C. All right, and then for number 7, the power function. Power functions are in the form y equals a times x to the nth power. All right, so that would resemble this. So if you think about multiplying all these out and writing it in standard form, you would take the biggest power in each one. So you have negative x squared times x to the third power, so there's a third power there, and we have x to the second power. So negative x squared times x to the third times x to the second is going to give us our power function. And if you combine all these, remember when you multiply the bases that are all the same, you add the exponents. So you have negative x to the 2 plus 3 plus 2, which is 7. So you have y equals negative x to the 7th, and that would be choice B. That's a power function that resembles the graph of f, resembles for large values of absolute value of x. And then finally, to round out this first page, we've got x-intercepts. So use the x-intercepts to find the intervals in which the graph is above or below the x-axis. Okay, so if I plot the x-intercepts, I know since x plus 3 is a factor, that means that x equals negative 3 is a 0 of multiplicity 2. And then since x minus 2 is also a factor, that means that 2 is a 0 also with multiplicity 2. Okay, so that means, and we know that the degree is 4. And if the degree is 4 and the the a is positive leading coefficient, we know the ends of the graph are going to be up like that. All right, so if we have an x-intercept where we touch, and we're going to be above, so we touch again, so we come up here like that, and we go down there like that. Now, find the intervals on which the graph of f is above and below the x-axis. So it's always above the x-axis, so it can't be above the x-axis, no intervals. It's never below the x-axis, never below the x-axis, so it's choice B, always above the x-axis.